Hello students. This particular presentation I will try to explain a bit more about the preparation of salts, which appear to confuse quite a few students from my experience. I will make it as short as possible. So let's start. Before we actually talk about preparing salts in the laboratory, there are 4 reactions that you should be familiar with. And from what I know, you should have encountered these 4 reactions from your lower secondary science. But nevertheless, here I will just quickly go through these 4 reactions. Now, the first one is basically neutralization. You get an acid plus alkali, and I believe you should know the products by now. If not, I strongly encourage you to go through your notes again. So it will give you a salt and water. Now, the second one is quite similar to the first one, except I'll be using a base. But let me just qualify here. My base in this case will be a metal oxide. Now, as I said, this is also a form of neutralization. It's basically an acid-base reaction, and of course it gives you the same products, salt and water. Now the third one involves acid too, and of course by now you realize that acids are commonly used in the lab and of course in industry as well. Now in this third reaction, I'll be using a metal carbonate. Right here, I'll give you a few seconds to figure out what the products are. Yes, salt is of course one of them. CO2 and water will be the other products. Now, the fourth one again involves an acid. Now, in this case, I'll be using a metal itself. Again, I'll give you a couple of seconds to think of the products that are given out in this particular reaction. Yes, you will definitely get a salt. And in this case, you get hydrogen gas as well. Now, a word of caution here, if you are using the last reaction, the method that we are typically using in the lab will be a relatively safe one, but yet not unreactive. Right, so in other words, you do not want something that can be hazardous, that can give you a very strong reaction. So in the lab, at least, do not use the top 3 reactive metals based on your O-level syllabus. So those top 3 will be potassium, sodium, and calcium. Alright, so take note of that. If such a question comes out in your test or exam, never ever use these 3 in their metal forms. And perhaps I would like to add to the first reaction. Alkaline in this case is typically a metal hydroxide. So let's move on to the next slide. Now, I will not touch too much on this. I assume you are already familiar about which are the soluble salts and which are the insoluble salts based on the O-level syllabus. And well, basically the more important classes of salts would be the chlorides, carbonates, and of course don't forget your sulfates and nitrates. And occasionally you may come across oxides, which is not exactly a salt, and hydroxides. Now, at the very least, know the soluble and insoluble salts under the first four classes of substances. Now, I don't really have an acronym or a shortcut for you to remember which are the soluble and which are the insoluble salts. Perhaps the only one I ever came across is this all spa salts are soluble. So SPA is an acronym for sodium, potassium, and yes, you get it, ammonium. Alright, so these three kinds of salts are soluble in water. Now let's move on to the actual preparation of salts. Now, well, there are various actually literature that give you various presentation of the methods in preparing salts, but here I'll use present based on the three methods as given in the latest textbooks for O levels. Now, the first method involves titration. And when do we actually use this particular method? To figure it out, you have to realize that titration involves reactant A plus reactant B to give you a salt. Now, note that here I use the terms reactant A plus reactant B. I did not mention which reaction you are using. Remember our four reactions as given earlier? It can be any one of them, right? Provided reactant A is soluble in water, so is reactant B, and so is your salt. Now, in this case, all your reactants and products are soluble in water. And keep in mind, now, besides salts, certain salts that are soluble, obviously, all acids are soluble in water, and all alkalis are soluble in water. But it doesn't mean that I have to restrict myself to acids and alkalis in this particular method of titration. So, one example. Let's look at HCl. Here I add in the state symbol of aqueous because it's soluble in water. NaOH, soluble in water too, so I use the state symbol of aqueous. And of course, everybody should be familiar with the product, sodium chloride, which is definitely soluble in water. Aqueous, state symbol, and of course, water, which was state symbol of liquid. Now, here you have a slight problem. Everything is soluble. How are you going to extract your salt, sodium chloride? And in fact, everything is colorless as well. So basically, you start mixing your reaction or reactants colorless, and you end up with a colorless product. Right. So, I won't go into too much details about this particular method of titration, but essentially, you need to do it at least 2 times. All right. So the first time is you determine the exact amounts of reactants to use in order to produce a certain amount of product, which is a salt in this case. Right, so Again, you do it through a titration using the suitable color indicator, and that will allow you to find out the exact amounts of reactants. Now, only in the second step, then you do a second titration using the exact amounts of reactants. But in this second titration that you do not add any indicator, because an indicator is going to contaminate your product. So by right, you should, at the end of the reaction, you should only have your salt and water. There should not be any excess acid or excess alkaline for this particular example. Now, as I was saying, for titration method, you need not restrict yourself to acids and alkalines. The key point is both your reactants are soluble in water. Your product, your salt, is also soluble in water. So it goes without saying you're supposed to be familiar with the solubilities of various salts, of various chemicals. Now, here's another example of titration. Now, in this case, let's say I have sodium carbonate. Now, this is, of course, soluble in water. So I put aqueous as the state symbol. And I decide to add an acid, let's say HCl. Alright. And all acids are soluble in water. Now, this is actually an acid metal carbonate reaction. Now, again, your products. I hope you guys are familiar with the products and how to balance chemical equations. Now, notice in this case, I get the exact same salt as the earlier example. Sodium chloride, again, is soluble, so I use aqueous as the state symbol. Now I get CO2, which is a gas, and of course I get water, which is a liquid. Now next, of course, I balance it up. Now, in case you didn't notice, the good news is CO2 is a gas, so this is going to escape from your reaction mixture and you won't have to bother about it. Now, as I was saying, both reactants are soluble in water. Your product is soluble in water too. How are you going to separate your product from the reactants? Now again, in this case, all your reactants are colorless. You started with a colorless reaction mixture, and of course you are going to end with a colorless reaction mixture. Now, so again, the answer is basically using the titration method. Therefore, I have to do two titrations. Alright, the first one is to determine the exact amounts of reactants. And the second titration, alright, so first one is to determine the exact amounts of reactants. And the second one, you use the exact amounts. And at the end of the second titration, you should end up with a reaction mixture that contains only your salt and water and no excess reactants inside. CO2, as mentioned earlier, should have escaped into the air, so that should not be a concern for you. Now let's look at the second method to prepare salts. Now this second method is known as using an excess reactant. Alright. Now, but I prefer to qualify this statement. This reactant has to be insoluble in water. Alright, so it looks something like this. So same thing, I have two reactants, A and B. Now, A is soluble in water, but B is not. So I use the state symbol of solid, and B is what I am going to add in excess. Alright, remember, even if you add in excess, it will remain as a solid unless it can react with A. And of course, your products, you get your salt plus other substances. Now, how about your salt? Now, in this particular case, your salt is expected to be a soluble salt. Alright, so whenever you're asked to prepare a particular salt, always ask yourself, is your product soluble in water? Alright, if it is not, then obviously you cannot use this method of excess reactant. Alright, in this whole reaction, the only insoluble compound will be one of your reactants. Now let's look at an example. Let's start with an acid, H2SO4, and you should be familiar with it by now. This is definitely soluble in water, as all acids are. Reactant B, let's look at copper carbonate. And again, if you remember your rules, this is insoluble in water, so I put a state symbol as solid. Now again, this is an acid metal carbonate reaction, so you will get a salt, and in this case your salt is copper sulfate. Now if you remember your rules again, you should know that this is a soluble salt, so I put aqueous here, and you get CO2, a gas, and water, a liquid. So notice I am following my rules for this particular preparation method of excess reactant. Alright, salt is soluble, one of the reactants is insoluble, and the other reactant is soluble. No, but why go to this extent? Why do I only want one of the reactants to be insoluble? Now the reason is I actually can add in my excess reactant B, because even I add in more, it will remain as a solid in my reaction mixture. Alright, so at the end of the reaction, this is what I will get. In my, let's say, beaker, I will have, of course, my salt. Alright, CO2 as always, this will have escaped into the atmosphere. Water, goes without saying, is still inside. And as I said, we have added excess copper carbonate. Now there should not be any acid because copper carbonate is the reactant in excess. So all the acid would have been used up. Now in this case, I'm quite confident of separating copper sulfate or copper sulfate solution because I can simply filter off my solid, which is copper carbonate. Alright, so what is left in the filtrate is simply copper sulfate and water. So that makes collecting my salt easier in the next few steps. Well, that was using the second method of an excess reactant, and the example I cited was an acid metal carbonate reaction. But can I have other reactions? Well, certainly. Here's another example of my method 2. Now in this case, let's start with sulfuric acid as well. Alright, by now I hope you guys are familiar with the state symbols, so I won't mention them anymore. Now, instead of using copper carbonate, I use another insoluble reactant, copper oxide. Solid in this case, since it's soluble in water. Now, I hope you realize this is actually an acid-base reaction. And of course, the products you get will be a salt and water. And notice in this case, I get exactly the same salt. Copper sulfate, which is of course soluble in water, and H2O. Now, again, based on the earlier description, this would be in excess since copper sulfate is my insoluble reactant. So, well, yeah, this is an acid-base reaction, but at the end of the reaction, what am I left with? The product, copper sulfate, which is what I want, water, and of course, copper oxide, which is in excess. Now, I go through exactly the same procedure. I filter off my copper oxide, since it's a solid, and of course, the filtrate will be left with copper sulfate and water. Now, let's go on to the last method to prepare salts. This is what we call precipitation. Now, precipitation simply means you want to produce something that is insoluble in water. In other words, you produce a precipitate, a solid compound which cannot dissolve in your reaction mixture. Now, it goes without saying, this method is used when you are preparing insoluble salts. So, look at your question carefully. Do you need to prepare an insoluble salt? If you do, then use this method and this method only. Well, we go back to the same pattern again. I have two reactants, reactant A plus reactant B, and that gives me the salts I want plus other substances. And what you need to know is your salt is insoluble in water, whereas both your reactants are soluble compounds in water. So remember this rule. To use precipitation method, you need to have two soluble reactants in order to get an insoluble salt. Now let's look at one example. So let's start with sulfuric acid, soluble, so I put it as equals, and barium hydroxide. Well, for O level we shall consider this as soluble. Well, and of course, you should recognize that this is an acid and this is an alkali. So of course, your products will be a salt and water. Now in this case, this is your salt, barium sulfate. Now if you remember your rules, this is an insoluble salt. Alright, balance it up. And well, there you have it. So at the end of your reaction, you are going to have, of course, your salt, which is a precipitate. Well, you may have an acid, you may still have your acid and alkali inside, but again, it doesn't matter, right? Because the next step is going to be a filtration step. you filter off your insoluble salt. So in this case, your salt should be in the residue from the filtration process. Now let's look at another example. And here I shall let you know that for this precipitation method, you may use a reaction that is not mentioned as one of the 4 reactions earlier. Right. So in other words, the reaction involving precipitation may not involve an acid at all. So here is one example. Now, let's say I want to prepare silver chloride. And if you're familiar with your rules, you realize that silver chloride is an insoluble salt. So the next question is, what reactants should you use? Well, obviously your reactant should include a silver compound and a chloride compound. Now in this case, basically for precipitation reactions, both my reactants should be soluble in water. So in this case, I shall use silver nitrate. And as all nitrates are soluble, this is definitely a soluble substance. And to provide the chloride, I'll be using your familiar sodium chloride, again definitely soluble in water. And here I have it. There is no acid involved. Instead, I have 2 soluble salts. That gives me an insoluble salt. Well, of course, you are still going to be left with your nitrate ions and sodium ions. Alright, which remain dissolved in water. But the key point is this. Whenever you have 2 soluble reactants or 2 soluble compounds and you mix them together, if there is a chance that an insoluble compound is formed, then this will definitely come out as a precipitate. So at the end of this reaction, oh by the way, silver chloride is white, a white solid. So at the end of this reaction, in your beaker, you will be left with silver chloride, a solid dispersed throughout the medium, and of course, as I said earlier, your nitrate ions and your sodium ions. Now, again, this is a very simple process to remove or to extract the silver chloride, again by filtration. And of course, this silver chloride will remain in the residue from the filtration. So I have basically covered the 3 methods to prepare salts. Again, if you look at different literature or different textbooks, you may be presented with different terminology, but essentially these 3 methods cover the common ones that are being used in the lab. Now, just one final point to note. Now, in all the, I would say in most of the earlier steps or the earlier 3 methods, alright, you are going to be left with a solution of salt. Alright, this is specifically for the first 2 methods. Alright, you are going to be left with a salt solution. And remember, your salt is soluble, at least for the first 2 methods. How are you going to remove the salt? Well, the standard answer is, if let's say you want an anhydrous salt, right? In other words, your salt is bone dry, completely dry, no water of hydration. So you evaporate to dryness. Right, assuming your salt doesn't decompose due to heat. Now, on the other hand, if you want a hydrated salt, now in this video I'm not going to explain about anhydrous and hydrated salt, so you may want to refer to other sources for that. So if you want to have a hydrated salt as the end product, then you do a crystallization step. Now the other situation is for method 3. Now for method 3, as mentioned, basically you have a salt, but in this case your salt is a precipitate, a solid, water and perhaps other stuff. So again, as mentioned earlier, you simply filter off and then you're left with residue. You're left with this residue containing your salt, which cannot dissolve in water, so it doesn't pass through the filter paper. So what you do is, the standard procedure is to wash with water, typically distilled water. Alright, then dry it, and for O-level syllabus you dry with filter paper by pressing it using filter paper, and there you have it. You have your final product. Alright, I have come to the end of this presentation. Hopefully you have learned something, and if necessary you can, well, email us, or if you are really interested, you can find out more about us by going to this website over here. Alright, so yes, that's all for today. Thank you for watching. Goodbye.